Okay, so now we're down to the last section in chapter 3. You may have noticed that there's not a whole lot of new information in each one of these sections. It's just a matter of getting all the information put together. If we were in the classroom, I would have you up at the board doing probably 2 or 3 of these in a classroom so we could all sort of work together and work this out. But that's not the way it is today, so we'll do the best that we can with it. So section 3.4 is just about setting it up in terms of section 3.3, in terms of your feasible regions only. Now, you knew it, it's coming, more than 2 variables. Chapter 4 is all about how to solve these things when there's more than 2 variables, because it's not necessarily going to be about graphing it. However, the end of section 3 or chapter 3 is about setting them up and not solving them. So you'll notice that the instructions on page 254 clearly say, do not attempt to solve these problems, but you are supposed to set them up. So what we're going to do is we're going to look at a couple of them. Your homework assignment is going to be 1 through 4 and then 6 through 10. I've set up a couple of these that are, number 5 is an example, and then we're going to work through number 12 and hopefully work through number 16. So the answer for number 5, it says, and it's got a nice little matrix there for you to use. So basically what I did was I looked down the wheat column because I know that I have 2,400 pounds of wheat. So I used A is the amount that you use for light, B is the amount that you use for trim, C is the amount that you use for regular, and D is the amount that you use for healthy fare. So for my wheat equation, then it would be from the matrix that it has there, it would be all of column 1 added together to get less than 2,400 pounds. For oats, which is column 2, it would be all of column 2 added together to get less than 1,400 pounds. Column 3, which is the raisin column, and you'll notice that it does not have a C in it. And that's less than or equal to 700 pounds. And for the nut column, then you'd add all those together and get less than or equal to 250 pounds. And of course, I needed to add on there, A is greater than or equal to 0, B is greater than or equal to 0, C is greater than or equal to 0, and D is greater than or equal to 0, because we know that we're not allowed to make negative amounts of items. The last function thing that we need to do then is come up with whether we're supposed to maximize or minimize, and in this one it's a maximize, and we need to maximize it, and it says the profit per pound in our matrix then, so the last column then is our maximizing function. So there's the answer for number 5. Number 12 is an entire word problem. So again, I'm just gonna sort of sort through the information. It's got graduate students, lecturers, professors. X is the number of graduate students. Y is the number of lecturers. Z is the number of professors. And this is the number of students that can be in the class. And you have 1,150 students. And then we have 60% more than the graduate class. So that 1.6 comes from 100% plus the 60% more. So 60% more than that would be 1.6 of that. And Z then says that you add the graduate students and the lecturers together to get something less than what the professors were. And again, X is greater than 0, greater than or equal to 0, Y is greater than or equal to 0, and Z is greater than or equal to 0. And it says in the very last sentence, find the number of sections taught by graduate students to minimize, this is not a maximum, this is a minimize the teaching cost. So that would be cost that much for a grad student, cost that much for a lecturer, and that much for a professor. Okay, so there's what you have for number 12. I did want to take a look at number 16. It's got to be less than or equal to $50,000. Okay. My camera's not very stable here. I'll try and make this work. Okay, and then it says that the first investment that you make, which is in stocks, is less than 40%. So if this is your first investment, so let's make A, stocks, and B, let's make those treasury bonds, and C, let's make those municipal bonds, and D, let's make those corporate bonds. Okay, so it says that they want 40% of their investment. So 40% of their investment would be 0.4 times A plus B plus C plus D. And that's the different construction on this one that we're looking for. So 40% of their investment is the maximum that they want for A. It says 15% of the treasury bonds, so again, the treasury bonds are B, and 15% of their total investment has to come from treasury bonds. For municipal bonds, it says 30%, so that's 0.3 times A plus B plus C plus D, and then 25%, which would be for D, which would be 0.25 times A plus B plus C plus D. So we have our maximizing function. We want to maximize the amount, and then we want to figure out how much we need to put in there to get the risk factors from each one of these kinds of stocks and bonds. So sorry about the camera bobble in there. We'll make it work. And again, all you had to do on these problems is set them up. So on the test, if it involves more than two variables, I'm not going to ask you to come up with a feasible region, but I am going to ask you to be able to set them up, find your maximum or minimizing the equation, and please make sure that you define your variables for that.